Okay, line 22, 7b97z56, Atomic Optical Dipole Force Coastal Navigation UFO 5G Wow Seti. There's the alien radio signal. And this is about Euler line, circumcircle, navigation triangles, keyword research for UFO space travel, charting and mapping of exoplanetary forces found in line 22 WOW data. So September 13, 2013 was when I was working on it. Today is October the 7th. The previous video is line 22, 7b97z56, Higgs, Drude electrons, piezoelectric crystals, UFO formula, 5G Wow Seti, line 22, 7b97z55, optical atomic forces, ladder pulse, laser fields, coherent formula, 5G Wow Seti. So I'm going to Google atomic pulse equations and quote the PDF file results from a blog. Okay, optical dipole force on ladder-like three-level atomic systems driven by chirped fuse cycle pulse laser fields. There's the name of the scientist. It's from June 2012, and it's arxiv.org. Quotes from wiki. There's a diagram here. An alternate method to determine the circumcenter is to draw any two lines, each departing one of the vertices at an angle with the common side, the common angle of departure being 90 degrees minus the angle of the opposite vertex. In the case of the opposite angle being obtuse, drawing a line at a negative angle means going outside of the triangle. In coastal navigation, a triangle circumcircle is sometimes used as a way of obtaining a position line using a sextant where no compass is available. The horizontal angle between two landmarks defines the circumcircle upon which the observer lies. The circumcenter's position depends on the type of triangle. If and only if a triangle is acute, all angles smaller than a right angle, the circumcenter lies inside the triangle. If and only if it's obtuse, has one angle bigger than at the right angle, the circumcenter lies outside the triangle. If and only if it is right triangle, the circumcenter lies at the center of the hypotenuse. This is one form of Thales' theorem. The circumcenter of an acute triangle is inside the triangle. The circumcenter of a right triangle is at the center of the hypotenuse. The circumcenter of an obtuse triangle is outside the triangle. The diameter of the circumcircle can be computed as the length of any side of the triangle divided by the sine of the opposite angle. As a consequence of the law of sines, it does not matter which side is taken, the result will be the same. The triangle's 9-point circle has half the diameter of the circumcircle. The diameter of the circumcircle of the triangle ABC is, and here is the calculation, where A, B, C are the lengths of the sides of the triangles, and S equals A plus B plus C divided by 2 is this semi-perimeter. The expression is this calculation there. Above is the area of the triangle. By Heron's formula, trigonometric expressions from the diameter of the circumcenter include that calculation. In any given triangle, the circumcenter is always collinear with the centroid and orthocenter. The line that passes through all of them is known as the Euler line. The isogonal conjugate of the circumcenter is the orthocenter. The useful minimum bounding circle of 3 points is defined either by the circumcircle, where 3 points are on the minimum bounding circle, or by the 2 points of the longest side of the triangle, where the 2 points define the diameter of the circle. It is common to confuse the minimum bounding circle with the circumcircle. The circumcircle of 3 collinear points is a line in which the 3 points lie, often referred to as a circle of infinite radius. Nearly collinear points often lead to numerical instability in computation of the circumcircle. Circumcircles of triangles have an intimate relationship with the Delaunay triangulation of a set of points. My thoughts. The star chart with global positioning system built within the memory of the piezoelectric crystals. And that would be from Arrow. Coastal navigation to keyword. The keyword navigational reference points. And I'm going to Google that. Google navigational reference points outer space in the next video. Thanks for watching.